The gradient function of f is given by f dash x is 12x cubed minus 24x squared. Show that the graph of y equals f of x has two stationary points. So we're going to want f dash x to be equal to 0, which means 12x cubed minus 24x squared is equal to 0. So 12x squared, x minus 2 is equal to 0, giving us x is equal to 0, or x is equal to 2. Determine the intervals for which the graph of the function is concave up. So we could use the second derivative here. And of course that's going to be 36x squared minus 48x. Now to be concave up, we need the second derivative to be positive. So 36x squared minus 48x, we need that to be positive. Now I'm just going to consider 36x squared minus 48x equal to 0 for the moment. Now we have a 12x we can take out, and then that gives us 3x take away 4. So x equals 0, or x is equal to 4/3. Now, let's just consider 36x squared minus 48x. We know it's 0 at 0 and 4/3. We also know that it's this shape because the coefficient of x squared is positive. So greater than 0 means out this way or back this way. So what we can say is that x is less than 0, or x is more than 4/3. Given that the graph of y equals f of x passes through 1, 0, determine f of x. Well, f dashed was 12x cubed minus 24x squared. So f dashed x is going to be 12x to the 4 over 4, which is 3x to the 4, take away 24x cubed over 3, which is 8x cubed, plus c. Sorry, that one's f, not f dashed. And it goes through 1, 0. So when x is 1, so 0 is going to be 3 take away 8 plus c. 0 is negative 5 plus c. c equals 5. So f of x is going to be 3x to the 4 minus 8x cubed plus 5. We now want to sketch the graph of y equals f of x, indicating all key features. Now of course we can use the calculator to help with this. So let's go to graph and table, and let's put in the curve. So we have 3x to the 4 minus 8x cubed, add 5, and we want to graph that. And we're obviously going to need to change the window a bit, so let's use what they've got here. So they've got negative 3 to 3 for the x's, and for the y's we've got negative 15 up to 20. So hopefully that will give us a reasonable picture, and here we go. So let's go for GSolve, and let's start with inflection. So we've got an inflection here at 0, 5. So just need to get my pen back again. So we've got an inflection there at 0.5. And are there any other inflection points? Yeah, we've got an oblique point of inflection here at 4/3. Well, we found the 4/3 before, and negative 4.48. So 4/3, what are these? 0.2, 0.4, 0.6, 0.8. So it's going to be in here somewhere. So somewhere around there. And then let's G-solve for that minimum down there. That's at 2, negative 11. And that's probably it, is it? No, probably should do roots actually. So G-solve root. So we've got 1 at 1. And what about the other one? That's at 2.57. So 2.2 to 4. So just before 2.6, around there. So other than that, what does it disappear off? It disappears off just around here somewhere. Comes down. We've got the point of inflection here. And then it comes over and it gets steep down here. Got to make sure it goes through that point. Takes this minimum down here, and then goes upwards like so. So this was a point of inflection. In fact, it was a horizontal point of inflection at 0.5, and we have a root at 1, 0. We had a root at 2.57, 0. We've got a minimum at 2, negative 11, and we've got an oblique point of inflection, and that was at 1.33 and negative 4.48. And that should be all the features we need to get all of these marks.